So after the housing and bank crisis, the European Commission managed to solve the problem by changing the rules from the top players, but the speculation has spread for those below in different areas, and the world still spinning. So let's say you want to put a bit of Industry 4.0 from the paper into action, but your boss doesn't open up the hand, not even to say goodbye to you. Well, we have to show him some tricks. And for this video I'm going to assume you have an old machine and you want to do some maintenance and quality control checkups, and you need data for it, and every time you have to do it on paper because the machine doesn't have any interface to do that, right? And your boss doesn't want to invest more money on an old machinery, but the machine is still running and you still have to do your job, and this video will serve that. So points to be considered for this video. While testing is okay to be a bit dodgy, you have to be cheap and afterwards show the result to your boss to impress them and to show them that Industry 4.0 it's important for all the engineers. But if you want to develop for permanent use, you have to consider some things, some points, and I'm not going to say all, but at least the important ones. Check for industry standards, ATEX, explosive environments, for instance. In these environments, we should not play around, and you have to develop your electronics adapt to that. Another point is if you want data for maintenance or quality control statistics, it's better to program with a real-time operation system. There are examples in internet how to program a microcontroller, for instance, with FreeRTOS. Yeah. In the European Union, not only in the European Union, but mostly it's where I am. Your electronics have to meet some industry standards, and to sleep well at night, you send them to a certified laboratory so they can recognize your product and certify your product. Yeah. Okay. The next thing is it's the electromagnetic perturbation, let's say so. So avoid placing next to big current conductors and high voltage sources. Yeah. The electromagnetic disturbances can most likely disrupt some electronics, especially at small signal systems. Yeah. So let's move on. So I had an old Omron PLC lying around with high-speed ports, inputs, and 2 racks, 1 input rack, 1 output rack, input and output. So the Omron PLC has some problems with high-speed ports, inputs and outputs. They burn, and I wanted to fix it, but it didn't end time for that. But for this purpose, for the purpose of this video, it will be enough because I want to simulate the old machine, and the inputs and outputs are fine. And that's the microcontroller MHTini, well, a cheap one, and you can program it with Arduino IDE. Yeah, just as simple as possible. So this is the microcontroller outputs. Going into the inputs of the PLC, I made this with leftovers, electronic leftovers. So I did not mention any values here because you have to calculate it yourself. Every project is a different project, so you have to look at PLC datasheet and see exactly what you are doing to calculate this resistance here. So for instance, the resistance R1, you have to calculate the capacitance of the MOSFET. So in order to the MOSFET to turn off, and I used an external 24 volt source to do this. So I'm going to need two of those circuits, two microcontroller outputs to trigger the two PLC inputs. And I have to go back to the dodginess. There's a professional way to do this, and the way is with optocouplers. Yeah. We don't want any currents, unwanted currents, to go into our microcontroller inputs and outputs. Well, and this is the professional way, and this way you can certify your product for the industries. Well, the inputs of the microcontroller are all pulled down, so it's a simple circuit in which I use the 5 volt source from the microcontroller board to go through the PLC and come back to the input of the microcontroller. And I used an external button, so we have two microcontroller inputs. It's relatively simple. The resistance R1 from the source, you have to calculate it also. And simple. So before we are going to the software, we're going to take a look at wiring of the small project. I added a reset PLC output port button, so I can reset the shift made to turn on the outputs of the PLC, and it's quite straightforward. I mean, like everything else in this project, nothing fancy. Yeah. So let's go to the software from the microcontroller, and I've declared the inputs and outputs and the data, the variable, in this case static variable, to transmit with 16 bits, 10101010, so I can see on the other side of the PLC and compare. And with a simple program that everyone should understand, yeah, right? So in this first stage of the program, if I press the button, it will come to this first stage, and this first stage puts the PLC in the ready to receive mode, and the input, it's made input from the microcontroller is made, and you send the data through this for loop. It's comparing the shift from the data and sending it. It's straightforward. Else, I program the LED so it can gives me some debug capabilities. Yeah, because if this data is not sent, the LED will turn on and off real quick, and gives me the idea that where I am in the program. So I put the LED with some debug capabilities. Yeah. So it's straightforward. I mean, nothing fancy. A small program. Yeah. It could become bigger if you used the real-time operation system, but for this case it's just to test how far we go. So another thing is the timings, the waiting time. Yeah, for this special set of leftover electronics and the PLC output sweeping port. I mean the refresh port from the PLC outputs and inputs. The PLC needs sort of 5 milliseconds to refresh all the ports. I mean, perhaps a bit longer. Yeah. And so this is the optimal set. I set a delay of 15 milliseconds between ons and offs from the signal. So in this special case, this is the limit. Yeah. In my special setup, I could perhaps push for a bit more if I could change the electronics setup and put some sort of push-pull behind of the MOSFET and use the input and output high-speed ports from the PLC, but I don't want to use it. I want to use the normal outputs and normal inputs from the PLC. But this is okay. I mean, this transmits with 50 hertz, almost 50 hertz. So you can send data very nice, as you are going to see in the video further ahead. Yep. So I flashed the MHDNI with micronucleus. Yeah, this takes you a bit, since you don't have a bootloader in this small and cheap microcontroller. The micronucleus program will do that for you, but it also takes away part of the storage to do that. So it creates some sort of a bootloader itself. Yeah. So this PLC software. In this case, the input is connected to the output of the microcontroller, and this input is also connected with the output of the microcontroller. So we're going to have a set of signals on and off to turn to put the PLC in read ready mode and put an output on to tell the microcontroller that he is ready to receive. So unless this is done with a set of bits and bytes, yes, and with a timer. So if this set, especially is specified set, is not made, and it will not come to the transmit clear to the and the microcontroller doesn't receive the signal in this time. So it's going to be, everything is going to be reset. So moving forward, there you go. This is the reset from the timer reset of everything with the first stage. And as soon as the microcontroller receives the PLC signal that is ready to read the shifted bytes, the microcontroller will do the for loop and send the bytes on and off accordingly to what we program to, and this is done with a shift resistor. And if one input is on and the other also is on, it's going to put 1 in this 16 bytes counted with a counter. Yeah, I mean, I could do it more bytes, but 16 bytes will be okay. And also I'm going to put also, I output also only 8 bytes. So 8 bits, sorry. So if both are on, it's going to put 1. If only the bit are off and bit clear on, it's going to put 0. And this is going to be counting, and will be only 16 bits put in the word 200L11, and this word going to be shifted, yeah. And as soon as the 16 bits counted 16 bits are done, the transmit clear will be reset. So the word is going to be put into the outputs. Not entirely 16 bits, like I said before, only 8. Only 8, because yeah, it's only to test. Only to show, only to test. And I have some button, input button, so I can move 0 to this shifted board to reset the outputs again. So I can do this over and over again with button from the microcontroller and the button from the PLC. Yeah, and that's it. It's simple, as always should be here, so everyone can understand this. So let's see the set in action, the whole project. So I made at this point with 20 milliseconds between signals on and off, and you see 10 10 10 in the outputs. At this time I will press the transmit button, transmit request, and it's going to put the outputs 10 10 10 as programmed. Yeah. I'm going to reset the output right now, and everything is back to 0. And it's going to do it again. Here we go. 10 10 10 in the outputs. You can see on the LEDs from the output rack, and online too. So you see. Now I could do this all day, and I just pushed several times, and this time I will put the 15 milliseconds between signals, so that's the limit. Yeah, without the push-pull transistor bridge into the MOSFET, this will not put a clear signal in the input from the PLC. So 50 milliseconds is the maximal that I can achieve. And I mean, I could do this all day. Push 2 buttons, 1 button to reset the outputs from the PLC, and the other button to ask the microcontroller to send the 16-bit to the PLC through the 2 input ports. So I need the 2 input ports and 1 output port from the PLC to do this. That's it. Next time I will make with another microcontroller, and I will try to fix and use the high-speed ports, but that will be perhaps in the third video. I want to push the maximum, and I will next time will extract data from the PLC. That's the most wanted one, so you can feed up so you can make some shards with maintenance or the quality control in several points of the machine, and that's the purpose for this video. Some sort of improvised Industry 4.0. That will be the next one.